Carolyn Boyce, and I'm currently pursuing a master's in educational technology through the University of South Carolina. I am currently a 5th grade science and social studies teacher and wrapping up my 3rd year of teaching at Inman Intermediate School. I am from Spartanburg, South Carolina.
Hi, my name is Allie Mathis. I am pursuing a master's degree in educational technology at the University of South Carolina, Aiken. I'm originally from Aiken, South Carolina, but now live in Lexington, South Carolina. I teach 8th grade math in Lexington, covering algebra and pre-algebra.
Hi, my name is Kenzie McGuire. I'm pursuing my master's degree in educational technology, and I am currently a full-time student athlete. The flipped classroom model, FCM, blends traditional learning with innovative learning. Students' first exposure to material is outside of class through an online platform. When students are in class, they are able to experience hands-on learning through activities using knowledge gained from video learning at home. Video-assisted learning gives students the opportunity to have deep reflective thinking, which is a necessary tool in learning. This model is different from the traditional model because the traditional model's first exposure is via a class lecture. Then students use their knowledge at home to complete homework. This is where the term flipped classroom comes from. The student's classroom setting is literally flipped. The importance of FCM is its ability to give students more freedom to access their instruction for a more accommodating learning environment. Studies show that FCM prepares students with the knowledge needed for successful hands-on learning in the classroom setting. A plethora of studies have been compiled on the flipped classroom model. However, not many focus on the upper-level elementary math content area. The purpose of this paper is to gather data on the impact of the flipped classroom model versus students in the traditional classroom model.
Flipped learning is a teaching strategy that front-loads instruction through pre-recorded lectures and lessons for students to watch before they attend class. There are many words that are synonymous to flipped learning, like flipped classroom and flipped instruction. J. Wesley Baker was the first person to advocate for flipped learning, and he believed that the benefits of flipped learning increase interactivity and collaboration into class and online without sacrificing any content. Flipped Classroom became popular in 2009 because it was student-centered. And then Bergman and Sams in 2012 became leaders in advocating for flipped learning because they saw that a framework for flipped learning ensures students receive a personalized education tailored to their individual needs. Bloom's taxonomy is also seen in flipped learning. Outside of the classroom, students are engaged in a lower-level thinking skills while watching videos through knowledge and comprehension. Inside the classroom, students participate in higher-level cognitive activities. Students perceive flipped learning in a very positive way. They are engaged in their learning. They also enjoy having the self-centered learning by being able to watch videos and content as many times as possible at home. They also really enjoy being able to work with their teachers more one-on-one and receive individualized learning. Here is a chart showing students' perception of flipped learning. Teachers also benefit from flipped learning because they're able to individualize content and turn into a mentor. They also are able to manage discipline better and are involved more with their parents. Students who missed or were absent are able to catch up through flipped learning. There are challenges to flipped learning. Not all schools are one-to-one. Students become passive learners sometime while watching videos at home, so teachers need to make sure they are making their videos engaging and changing. Students are also not able to ask questions at home. This has become possible now through Google Classroom having a comment section on each post that a teacher makes. Flipped learning in math. Studies show that flipped learning in math is very beneficial. Many students struggle with math content, so being able to watch the videos as many times as possible and at their own pace has helped students succeed. Also, students are needing individualized learning more in math compared to other classes. Teachers are now able to differentiate their math content easier with flipped learning.
For the methods of this study, for the participants, we plan to use 5th graders across the district. They will be split into 2 groups that will have flipped classroom instruction and traditional classroom instruction. We plan to make these as evenly matched as possible in terms of demographics. So we want to match socioeconomic level, gender, and race, and other demographics such as those to make sure there are no other factors besides flipped instruction and traditional instruction affecting the outcomes of this study. For design, we plan on using convergent parallel design, where we collect quantitative data and qualitative data simultaneously. This flowchart here shows a visual representation of what that will look like. After we collect all this data, we will merge the results and compare and then interpret what it means for this study in particular. For the materials, with quantitative data, we plan on using a pre-test and a post-test. This will be the exact same test students will take at the beginning and the end of the year. We also plan on using district common assessments for each unit so that they are being assessed in the exact same way, every single unit for every single topic. For qualitative data, we plan on evaluating the video lessons for their quality of instruction. We are conducting teacher interviews, student focus groups, and then there will be a parent-student survey on the Likert scale. The procedures for this. First, we're going to divide them into flipped or traditional. Like I said before, it is going to be as evenly matched as possible with demographics. Then we are going to prepare teachers a flipped classroom. Since this is something new for them, we want to offer them just a few suggestions, opportunities to learn a little bit more of how to best implement that, and offer them the opportunity to collaborate with each other, since this is a very new experience. So they are free to implement it in whatever way we want. We just want to give them the information. So after that will be the start of school. The students will take the pretest, and then whatever instruction they are assigned to will begin. So flipped instruction will start and traditional instruction will start. Throughout the year, a lot of our qualitative data will be collected. Teacher observations will be performed in the first and second semester. Each teacher will be observed twice. Focus groups will happen in the second quarter and the fourth quarter. Unit test scores will be collected as they come in, and video evaluations will be selected and done at random. And then at the end of the year, the parent-student survey will go out. Again, that is on the Likert scale, and then the post-test will be given as well. To analyze the data, for quantitative data, we're going to look at how students grew and compare that to what class they were in, what type of instruction they had. We're going to use the post-test and pre-test, but also we're going to see their growth throughout the year thanks to those district common assessments. For qualitative data, we plan on coding and comparing those results, and then to pull in the convergent parallel design that we are using, we're going to compare them to see if there's any kind of correlation between flipped classroom design and student achievement and student outlook.
The results from the study will show that a flipped classroom is more beneficial than a traditional classroom for 5th grade mathematical courses. The quantitative results will show an increase in test scores by students performing higher on the end of the year assessment and post-assessment from students in a flipped classroom compared to students in the traditional classroom. The qualitative results will show that a flipped classroom encourages students to be self-reliant learners and lifelong learners. The students will also show that flipping a classroom will increase class time for students to have more engaging instruction, which leads to more factual, conceptual, and metacognitive learning in the classroom. Finally, the qualitative results will show that flipping a classroom increases student learning interest, strong peer interactions, and improvement in learning performances. Overall, a flipped classroom sees better results and stronger results on assessments and on students' engagement in a classroom.
Through the proposed study, it will be clear that students gain learning benefits from the flipped classroom model. When compared to the traditional classroom, student engagement will score higher using FCM, which will lead to lifelong learning improvements. Teachers will be able to provide more engaging lessons with innovative instruction to help their students reach their highest potential. Due to the increasingly popular use of technology in the classroom, more studies should be dedicated to focusing on specific FCM for all content areas. Math is a challenging course for many students, and discovering how the FCM impacts their learning in this specific course could potentially prove beneficial to all learners and educators.
These are some possible questions we anticipate at the end of a presentation. 1 would be, what do teachers hope to achieve by flipping their classroom? 2, what do teachers do now that students are watching the lessons at home? And 3, how common is flipped learning in today's classroom? Our answers to these would be this. So teachers want to incorporate more individualized learning in their classroom so that they can cater to students' needs. In math, teachers are able to differentiate the math content to fit different levels of learning. In particularly, in a traditional classroom, the instruction happens in the class and the practice happens outside of the class. A flipped classroom does exactly that. It flips it. So inside the classroom is where all the practice comes. And because the teacher is right there to help the students with their practice, it allows the teacher to help guide that learning a little more. So students become less frustrated, they get their questions answered immediately, and deeper learning takes place. So in class now, students are engaging in those activities with their peers individually and with their teacher. So the teacher is able to answer questions students might have. It's not that they are going to have no work. They're actually going to probably work more in a flipped classroom because they are applying these skills instead of just learning those skills. They have a lot of time to apply these new things and really dive into that content and really make sure they are understanding exactly what is happening. 29% of U.S. teachers report using flipped learning in their classroom, and 27% of U.S. teachers plan to use flipped learning in the next year. So it is not as common as other types of learning, but it is growing because there are so many positive outcomes from it, and the student learning does grow so much that it will increase, and we plan to show how helpful this type of learning is to students through this study.
Here are the references used in our presentation and in our paper. Many references were needed in order to support our ideas and to research the topic more using flipped learning in a mathematical classroom.